In Lesson 3.5, the Pythagorean Theorem, you will be using the Pythagorean Theorem to find the missing side of a right triangle. You'll also be using the converse of the Pythagorean Theorem to determine whether or not a triangle is a right triangle. Over 2,000 years ago, there was an amazing discovery about triangles. In every right triangle, if you take the square of the two shorter sides, called the legs, and add them together, it will always equal the square of the longest side. That longest side of a right triangle is called the hypotenuse. It's the side that's directly across from the right angle, and it's also the longest side. Basically, what it says is a squared plus b squared equals c squared. That is called the Pythagorean theorem. You will want to make sure you have in your notes this drawing right here of a triangle. A and B are the two legs of the right triangle. They're the two sides that form the right angle. And C is the hypotenuse, or the longest side. And the Pythagorean theorem is a squared plus b squared equals c squared, or the sum of the squares of the two shorter sides equals the square of the longest side. This is only true for right triangles. You will want to have a calculator handy for this lesson as well. So in our first example, we're going to write an equation you could use to find the length of the missing side of each right triangle, and then we're going to go ahead and find the missing side, and we're going to round to the nearest tenth if necessary. Right up here I've put Pythagorean's theorem. Remember, A and B are the legs, or the two shorter sides, and C is the hypotenuse. What I'm going to have you do on your homework is always write down the Pythagorean theorem to start. A squared plus b squared equals c squared. And then before we start, I'm going to go ahead and label these sides so we know what we're talking about. A and B are the two that form the right angle. It doesn't matter which one you call A and which one you call B. I'm going to call this one A and this one B. And this one's already labeled for you as C. So we're going to take A and square it. So the next step would be to write 9 squared plus b squared, and b is 12, so 12 squared equals c squared. And we don't know what c is, so we're going to leave it as a c. Now the next thing you're going to do is you're going to go ahead and calculate 9 squared, which is 81, plus 12 squared. 12 squared is 144. In case you've forgotten, squaring a number means to multiply it by itself. So 9 squared is 9 times 9. 12 squared is 12 times 12. And again, we don't know what c is, so we're going to leave it as c squared. The next thing we're going to do is we're going to go ahead and add these two numbers together. 81 plus 144. That equals 225. And the other side is still c squared. Now, if I want to solve this equation for c, we want to undo the squaring. And to undo squaring, you want to take the square root. We're going to take the square root of both sides of the equation. The square root of c squared is just c. And the square root of 225, you want to know what number times itself is 225. You might know that that answer is 15, or you might want to use your calculator. Square root of 225 is 15. And in this case, it's going to be 15 inches because that is our label in the picture. So the unknown side is 15 inches. In our second example, B is what we don't know. Therefore, this one has to be A, because remember, A and B form the right angle. So AB, that means this one over here is going to be C. This is the hypotenuse. It's the one directly across from the right angle. We're going to start off by writing Pythagorean's theorem again. The more times you write it, the more likely you are to remember it. So a squared plus b squared equals c squared. A is 8, so 8 squared, plus b, we don't know what b is, so I'm going to leave that as a b, and c is 24, so 24 squared. Now, if I want to get b by itself, I'm going to have to get rid of this over here. But before we do that, why don't we go ahead and simplify this? 8 squared is 64. This is still going to be b squared. And then 24 squared is 24 times 24. 24 times 24 is 576. Now, if I want to get b by itself, I need to first get rid of this 64. To get rid of 64, I'm going to subtract 64 from both sides. When I do that, this will disappear, and I'll have b squared equals 576 minus 64, which is 512. Now we want to undo the squaring by taking the square root. The square root of b squared is b, and the square root of 512, that one is not a perfect square, so I'm going to go ahead and use my calculator. Square root of 512 is 22.627417. So I'm going to go ahead and round that to the nearest tenth. 22.62 is going to be 22.6 to the nearest tenth, and this is going to be in meters. 22.6 meters. Now, one thing I forgot to mention is that, remember, with square roots, there's actually always 2 square roots. It wouldn't make sense in this situation, though, to have the negative 15 or negative 22.6 because the length of the side is never going to be negative. You may want to pause the video and try the next two on your own. Remember, a squared plus b squared equals c squared. So I'm going to go ahead and label this triangle. Remember, the two legs are A and B, so the two that form the right angle are going to be my A and my B. This side right here is C. So A squared plus B squared equals C squared. A is 24, so 24 squared plus 18 squared equals C squared. "24 squared is 24 times 24, which is 576, plus 18 squared, which is 18 times 18. That's 324, is going to equal C squared. Now we're going to go ahead and add these two numbers together because they're both on the same side of the equal sign. So 576 plus 324, that's going to be 900. Now, to undo the squaring, remember you take the square root of both sides. The square root of 900 is 30. And the square root of C squared is C. And we only want the positive square root, so the answer is going to be 30 yards. In our next example, this one right here is labeled B, so this one has to be A, because remember A and B form the right angle, and that makes this one the hypotenuse, which is C. We're going to go ahead and write the Pythagorean theorem one more time. A squared plus B squared equals C squared. A is 3, so 3 squared, plus B, which we don't know, so we're going to leave that as B squared, equals C squared, and C is 8. Now let's go ahead and simplify this before we go to solve it. 3 squared is 3 times 3, which is 9. We're going to leave that as B squared. And then 8 squared is 8 times 8, which is 64. Now to get the B alone, I have to first get rid of this 9 by subtracting 9 from both sides. 9 minus 9 is going to be 0. 0 plus B squared is just B squared. And on the other side, 64 take away 9 is 55. Now you're going to go ahead and undo the squaring by taking the square root of both sides. Square root of B squared is B. Square root of 55, that is not a perfect square, so I'm going to go ahead and use my calculator. Square root of 55 is 7.416198. Keeps going. So to the nearest tenth, it's 7.4 or 7 4/10. And it's going to be 7 4/10 miles. Converse of Pythagorean theorem. If the sides of a triangle have lengths A, B, and C units such that C squared is equal to A squared plus B squared, then the triangle is a right triangle. Basically, if they give you 3 lengths of sides for the triangle, if you square the 2 smaller ones and add them together and it equals the square of the largest, it's going to be a right triangle. So in this example, it says the measures of 3 sides of a triangle are 5, 12, and 13. Determine whether the triangle is a right triangle. Basically, what we're going to do is we're going to take the 2 shorter sides and square them. So 5 squared plus 12 squared. And we're going to see if that equals the longest side squared. We want to see if that's true or not. I'm going to put a question mark there because that's what we're testing out. Well, 5 squared is 5 times 5, which is 25. And 12 squared is 12 times 12, which is 144. And we want to know if that equals 13 squared. 13 times 13 is 169. Well, 25 plus 144 is 169. Since 169 does equal 169, we have just proved that yes, this is a right triangle. You can pause the video and try the last one on your own. Determine whether the triangle with sides of given lengths is a right triangle. Justify your answer. You justify it by showing that it works in Pythagorean theorem or that it doesn't work in Pythagorean's theorem. So we're going to take the 2 shortest sides and square them. So 4 squared plus 5 squared, because remember it's the 2 shorter sides squared, has to equal the longest side squared. So we're going to test that and see if that's true. 4 squared is 4 times 4, which is 16, plus 5 squared, which is 5 times 5, that's 25. We want to see if that's equal to 7 squared, which is 7 times 7, or 49. 16 plus 25 . 16 plus 25 is 41. 41 does not equal 49. Therefore, it is not a right triangle.